The random variable x is the number of misprints per page in the first draft of a novel. So per page number of misprints, obviously it's a Poisson distribution, and they have mentioned it that it's a Poisson distribution. So question number A, state two conditions. Always write down the same answer no matter how many conditions they want. So events occur. Event is number of misprints. Misprints occur singly, independently, and at a constant rate. Question number B. The number of misprints per page has a Poisson distribution with mean 2.5. So per page, remember the interval is per page, so mean is 2.5. So we can define the distribution: number of events, number of misprints, and the unit is per page, and the distribution is going to be Poisson 2.5. This is for per page. If this per page changes, then lambda would change and the distribution random variable would change. The randomly chosen page has no misprints, so we have to find the probability of x equals to 0. We have to look up the table. So the table would be, this is the Poisson distribution. Value of lambda is 2.5. 2.5 is this column, and 0, x equal to 0 and x is less than or equal to 0 is the same thing. 0.0821. 0.0821. For question number C, the total number of misprints on two randomly chosen pages. Two randomly chosen pages means that we have to change the interval. So now we have y, number of misprints per two page. We have to change the random variable to y. So the Poisson distribution now, previously it was 2.5 for one page. For two page it would be 2.5 into 2, which is 5. And the probability we have to find, probability is usually given by more than, less than, exactly like that. So probability is more than 7 misprints. So y is greater than 7. In discrete distribution, greater than 7 means greater than or equal to 8. If something is more than 7, that means it is definitely going to be 8. The next one is 8. So y is greater than or equal to 8. That means 1 minus probability y is less than or equals to 7. So let me do it here. So 1 minus, if you look up the table, now we have to look up 5. Lambda, the value of lambda has changed. Remember, this is 5, and we have to look at x is less than or equal to 7. X is less than or equal to 7 is this one, 0.8666. 0.8666. So let's bring out the calculator. 1 minus 0.8666. That makes it 0.1334. Next question. The first chapter contains 20 pages. Now we have a new distribution where there are 20 page interval. So again we have to change the random variable. First we used x, then we used y. We cannot use z because the normal distribution uses the z-score z. We can use a. So a equals to number of misprints per 20 pages. So for one page it was 2.5. For 20 pages it would definitely be 50. Let's check. 2.5 into 20, that's 50. That means it's not in the table. If lambda is more than 10, we have to go to the approximation, and one way of doing that approximation is the normal approximation. To do an approximation is to convert the distribution completely into a different distribution so that we can go on with the sum. Now what is the sum? The sum is we have to find the probability less than 40. So the sum that we have to do, we have to find probability of A is less than 40. Fewer misprints. Less than 40 misprints. That means we cannot use this distribution because in the table lambda is up to 10. Whenever we have to go beyond 10 for Poisson distribution, we have to convert this useless distribution into a new distribution. So what distribution do we use? We use the normal distribution as an approximation. Using normal approximation for Poisson distribution. For finding the normal distribution, we need two values. The parameters for normal distribution, I'm just writing the letter X as a convention. So mean and variance. We need these two. So the formula says mu for the normal distribution conversion from Poisson is going to be lambda, which is 50. This is lambda. And sigma square is going to be lambda as well, again 50. So what alphabet can we use? We cannot use B because B is for binomial. We can use C. The letter C is free. So normal approximation, mu is 50 and sigma square is also 50. That means we have to find the probability using this. Now we need to do continuity correction. So A is less than 40. It would be, we have to make it less than or equals to. C is less than or equals to 39. Less than 40 means 39. It has to be equal to for continuity correction. That means if it is 39 and if we want less than, we have to start from here a bit earlier for the continuity correction. That makes it 40, 39.5, just 0.5 backwards. That makes it 39.5. That's the continuity correction. So C is less than equal to 39.5. Now the equal to sign doesn't matter at all. Now we have converted the discrete into the continuous using the continuity correction, because Poisson distribution was after all discrete. Normal distribution is continuous. Let's do the z-score. Therefore probability of z is less than, now I'm not going to use the equal to sign at all, it's not needed. 39.5 minus mean is 50 and standard deviation is square root of sigma. This is equals to probability of z is less than 39.5 minus 50 divided by square root of 50 equals to minus 1.485. Minus 1.485. In order to find the probability, we have to make this positive, so the inequality will be reversed, S1 rule. So less than would become greater than 1.485. Now we have to look up the table, but again this is greater than, we have to make it less than. 1 minus probability of z is less than 1.485. Now we are ready to look up the normal distribution table. 1.485 is around this column. 1.485, 1.485 means 1.49. That would be 0.9319. 1 minus 0.9319. If we subtract this from 1, that would be 1 minus 0.9319. That would be 0.0681. 0.0681. These are common terms that needs to be memorized. First of all, what is a sampling unit? A sampling unit is an individual item in a sampling frame. Remember, there are keywords to be memorized, so this is one of them. So you need to memorize this. Question number B. What's a sampling frame? A sampling frame is a list. A list of items in a sample. Next, question number C is a sampling distribution. Now you need to memorize this definition verbatim from the book, but one answer can be all possible samples are chosen from the population. This is pretty obvious. You choose all the possible samples from the population. Now when you take that sample and you find some statistic, this statistic can be the mean, the median, or anything. The statistic that you calculate, so the values of the statistic which is calculated from the sample. Statistic is any calculation made from the sample, like mean, mode, median. So the values of the statistic and their respective probabilities make up the sampling distribution. So what does that mean? This means if you have something like a table that we did in S1, a general probability distribution, this is the random variable and this is the probability. So the random variables are given here, suppose 0, 1, 2, 3, 4, 5, 6, 7, and each of their probabilities here. So this thing is called a probability distribution. Now if this random variable is some sort of a calculation made from a sample, that random variable would be a statistic.